Okay, mechanical properties of solids. In this case, mechanical means contact force. What we can write here? Contact force. Like friction, weight, tension. All these are the just like contact force. Okay. Next, properties. Properties of which material? Solids. Okay, solids. In this case, properties means we can write here behavior, behavior, behavior of the solids. When we apply some external force, like in the form of contact force, how the solids, metals behaves. Behavior means here we can write it here like hello everyone, welcome to ZOW 369 Energy of Physics. Today we will discuss about the uh, mechanical properties of the solids. Okay, so here mechanical properties of the solids. So in this case, first what we will discuss about that mechanical properties of solids. What is solid? Solid means made with more number of atoms, right? All these atoms are arranged in the regular pattern, regular pattern or orientation. Anything you can write it. Orientation. Okay. The example for solids is metals, metal wires, discs, cubes, etc. This is about the solids. And whereas mechanical means here we will discuss about the contact force. Which force? Contact force. Contact force means here like frictional force, friction, sometimes weight, sometimes tension, and like this. All are the examples for the contact force, right? Properties. Properties means behavior of the behavior of the solids like metals, disc, cubes. So in this case, behavior means what type of behavior we can discuss about this. Means when the contact force is applied on the solid materials, then how it can be elongate. Elongate means extension and compression and nature of the material. Nature means like elastic or plastic. So all these are the under the influence of the behavior. So now we will easily come to know that mechanical properties of the solids means whenever a contact force acts on the atoms or metal wires, depending upon the magnitude of the force, the metals may be elongates means change in length, and compression means change in length means decreases, and nature, what type of body, elastic or plastic, right? So all the solid atoms have a regular dimensions, particular dimensions like length, area, and volume. Length. By applying the external force, contact force acts on the solid materials. There may be change in its length, means increases or decreases. Change in its area, increases or decreases. And change in volume, same as it is increases or decreases. Under what conditions it will be changed? Only by the application of force, right? Whatever force, contact force. Okay. First, we will come to know what are solids. Okay, right. So in solids, all the atoms are arranged in the regular orientation. Okay, right? Atoms are arranged, arranged, arranged in a regular pattern or orientation, right? The first point. And the distance between any two neighboring atoms, NaGH kada, NeIGH, can write it here. Any two neighboring atoms are constant unless there is no force acting on it. Here, why it is constant means the force of attraction acts between the atoms for a certain limit. Okay, the force of attraction acts between the atoms for a certain limit. Limit means approximately 1 angstrom units, that is 10 power of minus 8 centimeter. The distance between the atom, neighboring atoms. So is equals to 1 angstrom. Solids have a definite shape and size. Like if you have taken this is the metal wire, it has length. If we consider a disc, a rectangular or square plate, we can consider plate. So for this area is there, A and B, length into breadth. So for this, what it has? Area. Area A equals to L into B. The another thing is volume. Imagine it is the cube. Okay, cube. x-axis, y-axis, z-axis. Length B, L, and this one is H. You can consider L into B into H. What it has? Volume. Right? Now this is the stress. How do we define the stress? Very simple. Stress is a restoring force per unit area acting on a body is known as stress. So restoring force means F by area of the material A. So we can write F equals to mg by area. We can write pi r square. In the case of metal wires, why we have written here G instead of A? Means here the body is does not move, doesn't free to move, so that we can consider here G. And what about unit force? The unit of force I am writing here unit. Force is Newton by area is meter square. Newton per meter square means it's a scientist name Pascal. This is Pascal. Okay. Next types of stress. The same as it is. The first thing is longitudinal stress. Longitudinal stress. The definition is almost the same. A restoring force per unit area. But in this case, what we can write it here. For example, we can consider it is the metal wire. Okay, and length is L and radius is R of this one, metal wire. If we apply some force on this body, the normal to this one, F, F. So both the forces are acting opposite side, outward, outward of the material, metal wire. So what will it is pulling outside and it is pulling out, means stretching like this. So then what will happen? There is a change in its length, means increases, means elongates. So such a type of stress is known as longitudinal stress. So here, what is the direction of the force we are applying? Means this cross section is there, no? This cross section, normal to the cross section, not in this way. It is outside this way. That's why we can say longitudinal stress. The formula is also be same. Here also be same like this. Okay. The next topic is tensile stress. This is quite opposite to the longitudinal. Like this is the metal wire and the force is acting on this one inward direction from both sides. Means what it is going to this compressed. So then what will happen here? The length decreases and the thickness will be increases. So such a type of stress is known as tensile stress. So the main important point in these two is in the case of longitudinal stress, length elongates. In the case of tensile stress, it will be compressed. Both the case, the force is acting on the normal to the cross-sectional area. You understand? Right. Take the screenshot. The next topic is shearing stress. Shearing stress, or the another name for this one is tangential. Tangential stress. Okay. For this purpose, we can imagine this: a book or a volume. We have to assume. So this is the a cube-like example. A book like this, and if the bottom of this book is fixed, bottom is fixed. Okay. If we apply the force, in which direction we have to apply the force? In this case, what will happen? The tangential, like this, tangential force in this direction. Tangential means which is parallel to the surface. If we apply here this force, or here this side or this side, this is not normal. But force is acting on this body only. So that's why we can say that is a tangential force. So how do we define like this? This is shearing stress is a shearing force or a tangential force per unit area. This is known as shearing stress or tangential stress. So in this case, what will happen here? Longitudinal stress, tensile stress, bulk stress, shearing stress. For all these type of stress, the unit is same. That is Newton per meter square, which is equals to Pascal. Thus named scientist name. Okay, right. Do you understand here? Very good. Next topic, strain. Stress is over now. Now it starts strain. Strain is when a body is subjected to stress, there is a change in its dimension. There is a change in its dimension. Okay. So we can define the strain is definition. Definition of strain. It's very simple. Strain is, it is the ratio of change in dimension to its original dimension. Original dimension. Remember this. Strain. Change in dimension to original dimension. It is the ratio. So how we can go define why it has to be changed means when a body is subjected to stress, there is a change in dimension. Initially it has certain length, certain area, certain volume will be there. When it is subjected to stress, what will happen? There is a change in its dimension. Maybe change in its length, maybe change in its area, maybe change in its volume. So that we can generally what we can define strain means very simple. This is it is the ratio of the change in dimension to its original dimension. So based upon the strain, there are three types of strains. One is longitudinal strain. Another one is lateral strain. Bulk strain. The last one is shearing strain. Okay, almost these two almost are same, but there is a change in dimension. For example, for this longitudinal strain, we can write it longitudinal means related to length. Therefore, we can write it here change in length by original length. Original length. Change in length means we can write it here the let us say delta L. Change in length delta L by its original length N. This is known as longitudinal strain. Whereas in the case of lateral strain, this is also this almost same, but here what we can write it here, change in its width, width or breadth by original width. If the change in breadth, let us say this is delta B by B. But you can understand that here, suppose for these two only I am telling about, if a metal wire has to be taken, it is the length, okay, certain length is there. So if I apply some force like this, if I elongate this one, stretch like this body will be elongated, means length increases. So this body is subjected to changing its length only. Whereas length changes, what about its width or thickness decreases. So that here longitudinal strain is related to change in length and lateral strain is related to only width. These two are always opposite to each other. When the length increases, it will be decreases. Okay. Next, bulk strain is also the same. This is changing volume by original volume. Okay, this is about the bulk strain. We can write the formula delta V by V, but we know that it is always, we can write it minus, because when your body is subjected to bulk stress, means it squeezes, so the volume will always be decreases. So that we, here we can take the minus sign. Shearing stress, shearing strain is also the same. The next topic is Hooke's law. Okay, Hooke's law, it states that the relation between the stress and strain of the elastic body or a metal wire length. So we can write it here uh, with the within the elastic limit. Within the elastic limit, this word is compulsory. Within the elastic limit. Hooke's law. It states that interrelation between the stress and strain of the object. So we can write it in the case of metal wires or any elastic body uh, within the elastic limit. This word is compulsory. We have to use within the elastic limit. The stress applied on a body is, the stress is directly proportional to the strain. The only the two words stress and strain. How it is going to be related? Directly proportional. Under what limit? Within the elastic limit. If it is beyond the elastic limit, the behavior of the wire or metal body will be changes. So that we can write it here. Stress is directly proportional to strain. Means stress is directly proportional to strain. Compulsory condition is within the elastic limit. So to avoid the proportionality, we can write one constant. Stress is equals to E into strain, where E is known as modulus of elasticity, modulus of elasticity. So that we can write E is equals to stress by strain. This is known as modulus of elasticity. Sometimes they may ask, define modulus of elasticity. It is very simple. Within the elastic limit, the stress is directly proportional to strain. Means the stress is increases, and the strain will also be increases. If the stress is removed, the strain will also be regains up to certain limit only. So this is known as Hooke's law. In the earlier classes, we have discussed about the stress and strain, types of stress, types of strains. There are three types of stress, three types of strains, and Hooke's law. And based on that Hooke's law, the modulus of elasticity is also be considered. Now, the modulus of elasticity is also be three types because stress is three types and strain is also three types are there. So we can write it here. Simple modulus of elasticity. The symbol for this one is E. So E is equal to simple. What's the formula for modulus of elasticity? This is the ratio of the stress to strain. But condition is applied that this is only within the elastic limit. Within the elastic limit. This is the condition compulsory. Okay. Now based upon the modulus of elasticity, E is also be three types. E is also be E is also three types. One is Young's modulus. Young's modulus. The other one is bulk modulus. Bulk modulus. Another one is the shearing modulus. The symbol for Young's modulus is Y, and the symbol for the bulk modulus is B, and the symbol for shearing modulus is eta. Sometimes we can also say that this is rigidity modulus. Rigidity modulus. Remember, this is rigidity modulus. Okay. Now define Young's modulus. What here modulus of elasticity is? It is the ratio of the stress to strain within the elastic limit. So same as it is, Young's modulus is also be defined as it is the ratio of the longitudinal stress by longitudinal strain. Simple. Stress by strain, but it is related to length only. That's why we can write it. Young's modulus is defined as the longitudinal stress to longitudinal strain. And formula for the stress is F by A. Stress means force by area. And longitudinal strain. How we have defined longitudinal strain is change in length to original length. So we can write it here delta L by F. That is equals to F by A. If it goes up, what will happen? It will be change A into delta. So FL by A delta L. Instead of F, we can also take this is mg also. Better. mgl by A delta L. So this is the formula for Young's modulus. Similarly, bulk modulus also. This is defined as bulk stress by bulk strain. Bulk stress means pressure. Force by area means pressure. By bulk strain. Bulk strain is related to change in volume. So that we can write delta V by V. Here we have taken the negative sign because the volume is decreases. Change in volume is always decreases. So that we can write it here P, it goes up PV by delta V. This is minus. So this is the formula for bulk modulus. And the last one is shearing modulus or rigidity modulus. So this is also very simple as it is like shearing modulus. So we can write it here shearing stress by shearing strain. Shearing stress to shearing strain. Stress again the force or force by area or simply we can write it pressure. Shearing strain we can write L by X. Change in its position, displacement divided by change in its displacement layer. Distance between the layers like this. So we can consider these three are the types of modulus of elasticity. So in this case, what you have to remember, Young's modulus is always related to only length consideration, and bulk modulus is only to the volume consideration, and shearing modulus is only the position of the particle or distance between the layers of the body. You understand here? No, no.